Hello learners, and welcome to today's lesson of factorizing quadratic trinomials. So let's start off our lesson with a did you know? So did you know that there are different kinds of expressions that can be simplified? We have linear expressions. An example there is ax plus c. We have quadratic expressions, which is ax squared plus bx plus c. And we have cubic expressions, ax cubed plus bx squared plus cx plus c. We actually even have more. But today, our focus is on factoring quadratic trinomials. Let's move on to our lesson. So by the end of this lesson, you will be able to factorize quadratic trinomials by expanding the middle term, factorize quadratic trinomials by trial and improvement, and simplify expressions. Looking at our concept map, we are going to be looking at 2 points today. So we are factorizing trinomials, where we are going to be factorizing trinomials in the form x squared plus bx plus c. We are also going to be factorizing trinomials in the form ax squared plus bx plus c, where that a is a common factor. We are also going to be solving problems where we are going to simplify algebraic expressions using factorizing. So let's look at the pre-knowledge that you should have for this lesson. So you should be able to factorize algebraic expressions with terms that have a common factor. You should be able to factorize an algebraic expression that is a difference of two squares, and you should be able to determine the factors of a given integer. Let's practice a bit of that pre-knowledge. Factorize the following expressions fully. So we've been given an expression there that is x exponent 4 plus 6x cubed minus 5x squared minus 4x. That expression there, if we look through all of those terms, we can see that there is a common factor. So what is that highest common factor there? That is x. So we can see that all four terms have x as a factor. So we are going to take out this common factor of x, and we are going to see what is left. Remember how we take out the common factor? After taking out that common factor, we are going to take each term and divide it by that common factor. That's how we factorize using the common factor. So now we are going to say x exponent 4 divided by x, and that is going to give us an x cubed. Then we are going to have the 6x cubed divided by x there, and that is going to give us there, we are adding there, and that is going to give us a 6x squared. And then we have there the 5x squared divided by the x, and that is going to give us there the 5x. And then finally we have a 4x, and we are going to divide it by that x, and that is going to give us there our 4. And that is how we factorize that. Let's look at another one where we are going to factorize by finding that highest common factor. So the next one that we've been given there is 12p cubed minus 3p squared plus 6p. So what is the common factor with that expression there? So if you look through that expression, we do have a common factor of 3, but that is not the only common factor that is there. We also have a p as the common factor. So we are going to take each term and divide it by 3p. So we are going to say 12p cubed divided by 3p, and that is going to give us a 4p squared. And then we are subtracting there. Then we are going to say that 3p squared divided by that 3p, that is going to give us a p that is left there. We are adding, and that last term there is going to be the 6p divided by the 3p, and that is going to leave us with just a 2. And then that leaves us there with a trinomial inside that bracket. And remember, every time we take out the common factor, we need to check, especially with the ones inside the bracket, just to make sure that there is no other common factor that can be taken out. Let's now look at factorizing with finding the difference of two squares. Remember, there must be a difference and there must be two square numbers. So here we go, we have k squared minus 16. Now both of them are square numbers, so we are going to have two brackets that are similar or have similar terms, and the only difference is that one bracket is going to be added and the other bracket is going to be subtraction. So the one bracket addition, the other bracket subtraction. K squared comes from k multiplied by k, and 16 comes from 4 multiplied by 4. One bracket is addition and the other bracket is subtraction. Let's look at the next expression there. We have 4x squared minus 36. 4x squared is a square number and 36 is a square number. So that's two brackets that are going to be similar. 2x multiplied by 2x gives us 4x squared. Then we have 6 multiplied by 6, and that gives us 36. Now, one bracket is going to be a subtraction and the other bracket is going to be an addition. It doesn't matter which bracket is the addition and which bracket is the subtraction, as long as one of them is an addition and the other one is a subtraction. The reason why it doesn't matter is because these two brackets are being multiplied. And remember, multiplication is commutative. So when you look in each bracket, it can further be factorized, because if you look at each bracket, we can see that there is a common factor. Let's look at this first bracket there. 2x minus 6. There's actually a common factor there of, yes, if you are thinking of 2, then you are correct. There is a common factor of 2 there. And when I say now 2x divided by 2, that is going to leave me with x. And then we are subtracting. And if we say 6 divided by 2, that is going to give me a 3. And that is how we factorize that first bracket. And when we continue with the second bracket, again, in the second bracket, there is a common factor, and that common factor is 2. Then we are going to say 2x divided by 2, that is going to leave us with x. And of course, we are adding in that bracket. And then we are going to say 6 divided by 2, that is going to give us a 3. And that is how we have factorized that expression fully. Then we have that last one there. We have 81 minus m squared. So both of them are square numbers there, which means, again, two brackets that are similar. 9 times 9 gives us 81, and m times m gives us m squared. One bracket is an addition and another bracket is a subtraction. Then we are looking at factors. So can we list the factors of the following integers? So now let's list the factors of 2, and that is a 1 and a 2. But what I need to remind you here of is that this is a positive 2. You need to remember that a positive 2, yes, can come from 1 multiplied by 2, but it can also come from a negative 1 multiplied by a negative 2. So 1 and a 2 and a negative 1 and a negative 2, all of those are factors of 2. Let's look at the 8. So what are the factors of 8? Now the factors of 8, we have a positive 1, a positive 2, a positive 4, and of course a positive 8. But in addition to these, we also have a negative 1 with a negative 2 and a negative 3. Sorry, not a negative 3, sorry, but a negative 4 and a negative 8. Because when we say negative 1 multiplied by negative 8, that gives us a positive 8. Negative 2 multiplied by negative 4, that gives us a positive 8. Then we have 24. The factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. And again, a positive 24 can come from a negative 1, negative 2, negative 3, negative 4, negative 6, negative 8, negative 12, and finally a negative 24. Those can also give us a positive 24. Then when we're looking at a negative 30, so those factors can be now a 1 and a, so those factors there can be a 1 with a negative 30. So for us not to get confused, I'm going to write them in pairs so that we understand there. So if I say 1 multiplied by a negative 30, that will give us a negative 30. And if I say 2 multiplied by a negative 15, that is going to give us there a negative 30. We can also say a 3 multiplied by a negative 10. That is also going to give us a negative 30. And we can say there a 5 multiplied by a negative 6. That is going to give us a negative 30. In that same way, we can also have a negative 30 being negative 1 with a negative 2 and a negative 3 and negative 5, but now a positive 6 and a positive 10, a positive 15, and a positive 30. So when we are listing down the factors of a certain number, just remember that it can be a negative or a positive because these are integers or factors of integers. Let's quickly look at the keywords that we are going to be using during this lesson. We have a trinomial, which is a polynomial with 3 terms. An example of this is 2x squared plus 3x minus 1. Then we have a common factor, which is a number that divides 2 or more numbers without leaving a remainder. For example, 2 is a common factor of 4 and 6. Then we have a fraction, that is a number that represents a part of a whole or a ratio of 2 numbers. So for example, 3 divided by 4 or 3/4 is a fraction represents 3 equal parts out of 4 equal parts. Then we have a numerator, that is the top number in a fraction. For example, in the fraction 2/5, the 2 is the numerator. And then lastly, we have a denominator, that is the bottom number in a fraction. For example, in the fraction 2/5, the 5 is the denominator. Let's quickly go to an ad break and then we'll see you just now.